Hello guys, let us proceed with our session, and this time we're going to look examples of longitudinal waves. Here I have just prepared for you two examples. The first example is sound wave. Therefore, among the examples of longitudinal wave is a sound waves. Let us see how sound waves is termed to be a longitudinal wave. Let us assume in this area we have air molecules which are moving randomly. Now this is the source of disturbance which will disturb these air molecules, and this source is sound. Now when the disturbance enters to the air molecules tend to move forth and back. They move like a swinging tree. Go forth, come back. Go forth, come back. Now, what this results to? This results to other regions in these air molecules, its particle will be very close to each other. The particles in other regions will be close to each other, but the particle on another regions will be far away from each other due to a swinging of these air molecules. And these regions, these ones where particles are close, is C, which is compression, and this one is R, which is their function. As you can see now, we are saying sound wave is a longitudinal wave. First, it gives us compression layer function, but also it does not change the shape of the medium. The shape remains to be the same, to have the molecules which are spread, but with sequence which is compression and layer functions. Therefore, from here we can conclude that sound wave produces longitudinal wave. Another example of longitudinal wave is spring wave. Spring wave is an example of longitudinal waves. How comes the spring wave was termed as transverse, but this time around is also termed as longitudinal wave? Here is the illustrations. Let us assume this is the spring which is here, which is tightened here. The spring is tightened here. One end of the spring fixed in. The other end of the spring, which is this one, is free. Now what are we going to do? We are going to pull the free end and also to push. We are going to pull, and you push the free end of the spring. Now what will happen? What will happen here? It will form the series of compressions where particles are close to each other. Particles are close to each other, and layer functions where particles are far away from each other. Compressions during pushing, layer function during pulling. Therefore, due to this factor, we are saying spring waves. A spring can produce which produces spring wave is an example of longitudinal wave. Now, you'd be asked, briefly explain how a spring can result into the formation of transverse and longitudinal wave. I think that question is very, very simple to you. Now let us go to another part, which is the last part of our session today, and this is talking about comparisons. We are going to compare between the transverse wave. We're going to compare between the transverse waves and the longitudinal waves. We want to see how are they relating. Now, the first relation is from their definitions. I think you know their definitions. Transverse particle direction and wave direction is perpendicular to each other. Longitudinal particle direction and wave direction are parallel to each other or are the same. But again, transverse, it forms crest and trough. But longitudinal, it forms compression and their functions. But also again, under transverse, we saw that transverse can travel only in solid, because solid has elastic media, and the transverse needs elastic media so that it can form crest and trough and to the liquid surface. But longitudinal can travel through all the media, solid, liquid, and gas, because what longitudinal waves needs is only the change in pressures, the change in volume, and the change in densities. Lastly, comparison is, due to this now, transverse, there is no pressure variations. Under transverse, there is no pressure variations. But and why no pressure variations? Because its surface is elastic. Molecules are not moving far away. They're remaining there. They're remaining intact. Therefore, that's why pressure is remaining the same. But here, molecules are traveling far away. Due to this, in longitudinal, for example, when you take a gas, because it can take place even in a gas, and longitudinal, now when you disturb a gas, when you disturb the gas area, the molecules moves far away, leads to difference in pressure. Hence now, under longitudinal, there is pressure variation. Now this is the comparison between transverse and longitudinal. Dear my students, at that point, this is the end of today's presentations. See you next time where we're going to see different things as wave concern. Bye.